short of extraordinary. Introduction. A Nimitz-class aircraft carrier isn't just a warship. It's a fully functioning city at sea. With a crew larger than most small towns, these carriers need water for everything: drinking, cooking, laundry, medical facilities, and even the reactors that power the ship itself. But unlike a city on land, there are no water pipes, no reservoirs, no water towers, just millions of square miles of undrinkable salt water. So how do they do it? How does a carrier take seawater, filled with salt, minerals, and impurities, and turn it into crystal clear drinking water that meets the same standards as your tap at home? The answer lies in some of the most advanced desalination technology ever created, powered by the one thing these ships have in unlimited supply: nuclear energy. And the system that makes it all possible is an engineering marvel that most people never even know exists. If you've ever wondered how our military stays self-sufficient at sea, drop a comment below and let us know your thoughts. Let's start with the basics. A U.S. Navy aircraft carrier is one of the most powerful machines ever built. At over 1,000 feet long and weighing more than 100,000 tons, it's essentially a floating airport. But it's also a floating town. The crew lives on board for months at a time, sometimes 6 months or longer without touching land. That means every single need, food, medical care, equipment maintenance, and of course water, has to be met right there on the ship. Now, the average American uses about 80 to 100 gallons of water per day. Multiply that by 5,000 crew members, and you're looking at hundreds of thousands of gallons needed every single day. But that's just for personal use. The ship itself needs even more. The nuclear reactors need water to generate steam. The catapults that launch fighter jets need water. The kitchens, the medical bays, the firefighting systems, they all depend on a constant supply of fresh, clean water. And here's the challenge. The ocean is full of water, but you can't drink it. Seawater contains about 35,000 parts per million of salt. Drinking it would dehydrate you faster than drinking nothing at all. Your kidneys would pull water from the rest of your body just to process the salt, and you'd be in serious trouble within hours. So, how do you solve that problem when you're hundreds of miles from the nearest shore? The answer is desalination, the process of removing salt and impurities from seawater to make it safe to drink. It's not a new idea. Sailors have been trying to figure this out for centuries. In the 1700s, ships carried primitive distillation devices that boiled seawater and captured the steam. It worked, but it was slow, inefficient, and dangerous. Fast forward to today, and the technology has evolved into something far more powerful. Modern U.S. aircraft carriers use two main methods to produce fresh water: flash-type evaporation and reverse osmosis. Both systems are incredibly effective, but they work in very different ways. Let's talk about the flash evaporator first. This is the system most commonly used on nuclear-powered carriers, and it's a perfect example of how the Navy takes advantage of the ship's massive power supply. The carrier's two nuclear reactors generate heat through nuclear fission. That heat is used to create steam, which powers the ship's turbines and propels it through the water at over 30 knots. But the Navy found a way to use that same heat for something else, making fresh water. Here's how it works. Seawater is pumped into a series of chambers inside the evaporator. These chambers are kept under a vacuum, which lowers the boiling point of water. Normally, water boils at 212 degrees Fahrenheit, but under vacuum pressure, it can boil at much lower temperatures, sometimes as low as 100 degrees. This is important because it means the system doesn't waste energy overheating the water. As the seawater enters the first chamber, it gets heated by the ship's nuclear reactor system. The water flashes into steam almost instantly. That steam rises to the top of the chamber, leaving behind all the salt, minerals, and impurities. The steam is then passed through a condenser, where it cools down and turns back into liquid water, but now it's completely pure. No salt, no contaminants, just clean, drinkable water. But here's the genius part. The leftover brine, the super concentrated salt water that didn't evaporate, gets pumped into the next chamber, where the process repeats. Each stage pulls out more fresh water, and the brine gets more and more concentrated. Eventually, that brine is discharged back into the ocean, far from shore to avoid environmental impact. Each Nimitz-class carrier has 4 of these evaporators. Each one is capable of producing 100,000 gallons of fresh water per day. That's 400,000 gallons total, every single day, without ever running out of fuel or needing a resupply. Quick question for you. Do you think this kind of technology could help solve water shortages back home? Drop your answer in the comments. Now let's talk about the second method, reverse osmosis. This system is newer, more compact, and doesn't rely on heat. Instead, it uses pressure, a lot of it. Reverse osmosis has become the standard on many smaller Navy ships, and it's also used as a backup system on carriers. Here's the concept. Seawater is forced through a series of extremely fine membranes at high pressure. These membranes have microscopic pores, so small that only water molecules can pass through. Salt, minerals, bacteria, and other impurities are too large to fit, so they get filtered out and flushed away. What comes out on the other side is pure water. The process happens in multiple stages. The first stage removes larger particles and sediment. The second stage filters out finer impurities. By the time the water reaches the final membrane, it's already incredibly clean, but the Navy doesn't stop there. After filtration, essential minerals are added back into the water. Why? Because completely pure water, water with 0 minerals, doesn't taste good and isn't ideal for long-term consumption. Adding minerals back in makes the water healthier and more palatable. Reverse osmosis systems on Navy ships can produce around 12,000 to 100,000 gallons per day, depending on the size of the unit. They're quieter, more efficient, and require less energy than evaporators. But they do have one downside. The membranes need regular maintenance and replacement. Saltwater is tough on equipment, and over time those membranes can get clogged or damaged. So now you've got hundreds of thousands of gallons of fresh water being produced every day. But the process doesn't end there. That water still needs to be treated before it's safe to drink. After desalination, the water goes through a chlorination process. Small amounts of chlorine are added to kill any remaining bacteria or microorganisms. The Navy follows strict guidelines set by the Bureau of Medicine and Surgery to ensure that every drop of water meets the same safety standards as water in the United States. Once treated, the water is stored in massive onboard tanks. These tanks are dedicated solely to potable water, nothing else. They're regularly inspected and cleaned to prevent contamination. From there, the water is pumped throughout the ship to galleys, berthing areas, showers, sinks, and medical facilities. Sailors can fill up their water bottles, take showers, wash their uniforms, all without worrying about running out. But here's what really sets these systems apart. They never stop. As long as the reactors are running, the desalination plants can keep producing water. And since the reactors are nuclear, they can run for 20 years or more without refueling. That means a carrier can stay at sea for months, even a full year if needed, without ever needing a single drop of water from shore. Compare that to older ships that ran on oil or diesel. Those ships had to carry their fresh water in storage tanks, and once it ran out, they had to resupply. It limited how long they could stay deployed and where they could go. Nuclear carriers don't have that problem. They're completely self-sufficient. Before we go any further, take a quick second to hit that like button and subscribe if you haven't already. Over 98% of you are watching without subscribing. It costs you nothing but helps us keep bringing you content like this. We really appreciate it. Now let's talk about the people who make all of this work. Operating a desalination plant on a nuclear-powered aircraft carrier isn't something you can do with the push of a button. It requires a team of highly trained sailors known as machinists' mates. These men and women are responsible for keeping the water systems running 24/7. They monitor temperatures, pressures, flow rates, and water quality. They perform maintenance, troubleshoot problems, and make repairs, often while the ship is in the middle of a combat zone. It's not glamorous work, but it's absolutely critical. Without clean water, the entire ship would shut down. The crew couldn't eat. The reactors couldn't run. The medical staff couldn't treat injuries. The whole operation depends on these systems working flawlessly, day in and day out. And it's not just about drinking water. Remember, the ship also needs water for its steam plants. The catapults that launch fighter jets off the flight deck use steam pressure. The turbines that drive the propellers use steam. Even some of the ship's defensive systems rely on steam. All of that steam comes from water that was once salty ocean water. The desalination plants provide the raw material for nearly every system on board. In a way, these systems are the lifeblood of the carrier. They keep the crew healthy, the equipment running, and the mission on track. And they do it all silently, behind the scenes, while the rest of the world focuses on the fighter jets and firepower. Here's something to think about. Would you trust water made from the ocean more than tap water at home? Let us know below. Let's put this technology into perspective. A single Nimitz-class carrier produces 400,000 gallons of fresh water every single day. That's enough to supply a small town. In fact, during natural disasters like hurricanes or earthquakes, the Navy has used its carriers to provide emergency drinking water to coastal cities. When Hurricane Katrina hit New Orleans in 2005, Navy ships were among the first responders. They pulled up to the coast and started pumping fresh water directly to people who had lost everything. The same thing happened after the earthquake in Haiti in 2010. Carriers and other Navy ships anchored offshore and provided clean drinking water to tens of thousands of people. The desalination systems that keep sailors hydrated at sea also became life-saving tools for civilians on land. This is one of the things people don't always realize about the military. Yes, these ships are built for combat, but they're also built to help. They carry medical facilities, food supplies, helicopters for rescue missions, and the ability to generate power and water from nothing but seawater and nuclear fuel. In a crisis, they can be the difference between life and death for thousands of people, and the technology keeps getting better. The newest class of carriers, the Gerald R. Ford class, has even more advanced systems. The lead ship, USS Gerald R. Ford, was commissioned in 2017, and it represents the cutting edge of naval engineering. It still produces 400,000 gallons of water per day, but it does so more efficiently. The ship uses less energy overall because it replaced the old steam catapults with electromagnetic ones. That means less demand on the steam plants, which frees up more capacity for desalination and other systems. The Ford-class carriers also have better automation. Older carriers required large teams of sailors to operate and maintain the water systems. The new ships can do a lot of that work automatically with computerized monitoring and control. That means fewer crew members are needed, which lowers costs and makes the ship easier to run. But the core technology is still the same. Take salt water, remove the salt, and turn it into something you can drink. It's a process that sounds simple but is incredibly complex in practice. You're dealing with corrosive salt water, high temperatures, extreme pressures, and equipment that has to work perfectly for months at a time. There's no room for error. A failure in the desalination system could put the entire crew at risk. That's why these systems are built with multiple backups and redundancies. If one evaporator fails, there are 3 more. If a reverse osmosis unit goes down, there's another one ready to take over. The Navy has spent decades perfecting this technology. It's been tested in every ocean, in every climate, under every condition imaginable. From the freezing waters of the Arctic to the scorching heat of the Persian Gulf, these systems have proven themselves over and over again. They're reliable, efficient, and powerful. And here's something most people don't think about. This technology isn't just military. It's being used all over the world to provide fresh water to places that don't have it. Countries in the Middle East, where freshwater sources are scarce, rely heavily on desalination plants. Saudi Arabia, for example, gets more than half of its drinking water from desalination. Israel, the United Arab Emirates, and others do the same. The technology that was developed and perfected on Navy ships is now helping millions of people survive in some of the driest places on Earth. Do you think more cities in the U.S. should be using desalination to deal with droughts? Comment your thoughts. Let's wrap this up by talking about what all of this really means. A U.S. aircraft carrier isn't just a weapon. It's a symbol of what's possible when you combine engineering, innovation, and the will to solve impossible problems. The fact that a ship can take salt water, something completely useless to humans, and turn it into hundreds of thousands of gallons of drinking water every day, is nothing short of remarkable. It's a reminder of how far we've come. A few centuries ago, sailors died of thirst while surrounded by water. They had to ration every drop, and long voyages were deadly because they simply couldn't carry enough fresh water to survive. Today, a modern carrier can stay at sea for a year or more, supporting thousands of people without ever needing to resupply water. That's progress. That's the power of human ingenuity. And it's not just about survival, it's about strength. The ability to stay at sea indefinitely gives the United States a strategic advantage that no other country can match. Our carriers can go anywhere, stay as long as needed, and operate completely independently. That's power projection at its finest. It's what keeps our forces ready, our allies protected, and our enemies thinking twice. The men and women who serve on these ships deserve our respect. They're operating some of the most advanced technology in the world, often under difficult and dangerous conditions. They're away from their families for months at a time. They're doing a job that most people will never see or understand. But every day, they're proving that the United States Navy is second to none. So the next time you hear about a carrier strike group deploying somewhere across the globe, remember this: they're not just bringing firepower. They're bringing a floating city, powered by nuclear energy, capable of producing its own water, its own electricity, and its own food. They're self-sufficient. They're unstoppable. And they're a testament to American innovation and military strength. Conclusion. From saltwater to drinking water, from seawater to steam power, the systems on a U.S. aircraft carrier are nothing short of extraordinary. They prove that with the right technology, the right training, and the right people, anything is possible. If you found this video fascinating, make sure to hit that like button and subscribe for more content like this. There's a lot more to uncover about how our military operates, and we're just getting started.